What? How come I die? What? What's that?
In order for you to understand the mathematics behind the Peeker's advantage that you just saw, it's necessary to understand the basic concept of a vector equation of a line. We can first start with the Cartesian equation of a line, which is in the form of y equals to mx plus c. Let's say we have an equation of y equals to 2x plus 1. A vector equation of line has three components: a position vector, a direction vector, and a coefficient lambda. On this line of y equals to 2x plus 1, we can find a position vector first. Let's just say the most obvious one, 0, 1. Instead of coordinate form that is horizontally placed, we have to write it in the column form, which means it's a vector going from 0, 0 to 0, 1, rather than a pure coordinate. The direction vector, as its name suggests, dictates the direction of this line. Since the gradient of this line is 2, which means as the x value increases by 1, the y value would increase by 2. Therefore, our direction vector would be 1, 2. By substituting different values of lambda, we can get any point on this line. But there is one thing that you have to be aware of. There could be only one equation of a line in the Cartesian form, but there might be infinite ways to express an equation of a line in the vector form. By choosing different direction vector and position vector can end up giving you the same equation of a line. For example, instead of 0, 1 as our position vector, we can choose 1, 3 as our position vector as well. Also, instead of 1, 2 as our direction vector, we can choose 2, 4 as the direction vector as well. The only difference is that we would get different number of lambda. Now, going back to this scenario, the holder is stationary all the time, so its position can be modeled quite easily. But however, the peaker is moving all the time, so we have to use what we have just learned, the vector's equation of a line, to model its movement. The setup is that, since from the bird's eye view, a person's length is definitely bigger than a person's breadth, so we are going to assign the length of a person as 2 and the breadth of a person as 1. And its line of sight is directly in front of its body and in the middle of its length. From the ascent map, we can see that the box is approximately 5 times larger than its breadth. So we are going to assign it as 5 times 5. For the purpose of simplicity, I'm going to assign the left back of the holder as 0, 0. The left front edge of the box would be 2, 5. And the starting point of the peaker would be 14, 14. In this scenario, the peaker knows that the holder is hiding right behind the box because the peaker's teammates got killed. So therefore, the peaker is peaking at an angle, let's say 30 degrees. Now we can describe the motion of this peaker using what we just learned, the vector equation of a line. Since the starting point of the person is 14, 14, then the position vector is also 14, 14. But be careful, it's in column form. Then, since the person is peaking at a 30-degree angle, using simple trigonometry, the direction vector of the person would be negative root 3 and 1. The negative sign in front of square root 3 suggests that the person is moving in the negative x direction. Now we have used the concept of vector equation of a line to model where the person's head is moving. Now we have to create another vector equation of a line of this person's line of sight passing the box. Well, since we can choose any starting point in a vector equation of a line, we can choose 2, 5 instead of a moving line of sight. For the direction vector part, we have to use vectors addition and subtraction. So first, the x value of this direction vector will be 14 minus square root 3 lambda minus 2 equals to 12 minus square root 3 lambda. And the y value of this direction vector would be 14 plus lambda minus 5 equals 9 plus lambda. Since we already assigned the coefficient lambda for the first equation of a line, we are going to use mu for this time. So the equation of the peaker's line of sight passing the box would be 2, 5 plus mu times 12 minus square root 3 lambda, 9 plus lambda. Now we want to solve what value of mu, meaning how much the person peaks, would he see the holder's shoulder first. Since the person is peeking to the left shoulder of the holder is 0, 1, so we just equate the equation of the person's line of sight to its shoulder. By putting this into numerical solver, we get that lambda equals to 3.36, meaning that if the peeker peeks 3.36 units, the peeker would see the holder's left shoulder. But this is not enough. In order to explain peeker's advantage, we have to switch the perspective to the holder as well to see what's the difference from his eyes. The first step is constructing the holder's line of sight passing the box. But be careful, the coordinate of the holder's head is not 0, 1 anymore, because we have established that a person's head is in front and in the middle of its body. Therefore, the position vector of the line of sight is 1, 1 instead of 0, 1. For the direction vector, we are going to use the edge of the box again, which is at 2, 5. Doing a set of vectors subtraction again. 2 minus 1 equals 1, and 5 minus 1 equals to 4. So the direction vector will be 1, 4. Putting them together, then the line of sight of the holder can be expressed as 1, 1 plus mu times 1, 4. Since the peeker is moving approximately to the left, then the holder would first see the peeker's right shoulder first. So the position vector of the moving peeker is not 14, 14 anymore, because 14, 14 represents the position of its head. Therefore, the x and the y value should both decrease by 1 unit. So the x value should be 14 minus square root 3 lambda minus square root 3. And the y value would be 14 plus lambda plus 1. Now the left side of the equation is 1, 1 plus mu times 1, 4. And the right side of this overall equation is 14 minus square root 3 lambda minus square root 3. 14 plus lambda plus 1. Putting this into the numerical solver, we get lambda equals 3.92. Now we can do some analysis on the result. For the peeker's line of sight, the peeker has to move 3.36 to first see the left shoulder of the holder. But from the holder's perspective, the peeker has to move 3.92 units so that the holder can see the peeker's right shoulder. In this 3.92 minus 3.36 unit, which is 0.56 units, the holder is not able to see the peeker, but at the same time, the peeker is able to see the holder's left shoulder. Well, that explains why, in the clip at the beginning of the video, the holder is getting killed without seeing the peeker. Well, thank you so much for watching. I will bring out more amazing mathematical knowledge about Valorant next time.